Um, this meeting is being recorded just so that everybody knows. Um, so welcome everybody. I'm so happy to have you here for today's online Python session. And before we begin, I'd like to briefly share that this class is brought to you by Strategic Minds Foundation. Strategic Minds Foundation offers free online learning sessions for kids, engaging, fun, and designed to help children strengthen their academic skills outside the classroom. At the heart of Strategic Minds Foundation is a deeper mission: to make education more accessible for all. In addition to providing free online classes, the foundation is dedicated to helping underprivileged children get basic school supplies. A little bit about me. So I'm really passionate about technology and teaching. I got first place in the FBISD district coding competition and second place in the district robotics competition. And I'm also the lead programmer for my robotics team. Some rules for the class. Please raise your hand if you want to speak, and I'll give you a chance to talk. Please use your real name when joining the class. Be respectful to everyone, because kind words and listening ears make a great learning space. And please be respectful of everyone's time by staying focused and ready to learn. Keep the chat related to the topic so we can all stay on track and get the most out of our time together. And now, let's jump into it. So real quick, we're just going to do a quick recap of what we covered in the last class. So some of the math operations, we talked about math operations like subtraction, addition, which is subtraction the minus, addition the plus. We have a minus again, that's just subtraction, it's a typo. We have the asterisk, which is for multiplication, and we have this forward slash, which is for division. Now some other math functions that we talked about include the max function and the min function, which basically give you the maximum or the minimum of two numbers entered separated by a comma inside of the parentheses. Right? The power function, which will give you the first number raised to the second power. The square root function, which gives you the square root of the entered value. The floor function, which gives you the least integer, which gives you the greatest integer that is less than the given value. So for example, if you were to do floor of 3.14, this would give you 3. And similarly, ceiling is the greatest integer or the least integer greater than the entered value. So if you were to do ceiling of 3.14, it would be 4. Now the absolute value just ignores the negative sign of the number. So absolute value of -5 is just 5. And if there's no negative sign, then the absolute value of the number is just a number. So what do you think the absolute value of 7 would be? Yeah, the absolute value of 7 is just 7. Because there's no minus sign, it just stays the same. We also talked about some conversion functions like float and int. And what these do is that they take the given input and they convert it to a float or an int. So for example, if we were to enter 3.14 into input, what this would do is it would take the string of 3.14 and convert it to a number, like a float, that we could actually use to do math. We also talked about string operations, like length or len, which gives us the length of the string, the square brackets, which give us the particular index, or which give us the particular character at a specified index of the string. We talked about the index function, which gives the index of a string or a character inside of the string. The replace function, which can replace portions of text inside of the string. The isUpper function, which returns a boolean of it being true or false, and the lower and upper functions, which convert a string to all lowercase or all uppercase. Any questions? Okay, no questions. Let's continue. So today we're gonna start off by talking about lists, right? And lists are basically collection of values. So the way that you create a list in Python is that you have the variable name, which is what you want to call the list. Hello. I just want to let you know that this meeting is being recorded. Um, so I'll continue. So we today we're going to talk about lists, and the way that what are lists are collections of values, and the way that we create a list in Python is that we would put the name of our list, and then we do equal to, and then we use square brackets to enter um to specify what is inside of the list and what is outside of the list, and then we put the values separated by a comma. So what does this look like, right? So we have our list. So over here in the bottom, we have my list, which is the name of our list, and then we have the elements of the list, which are 3, 4, 6, 10, 8, right? And they're all separated by commas. So we separate them by commas to tell Python that these are all different elements. And then this is just a graphical representation of the lists with indexes. And we'll talk about indexes next, right? So how do we access the different values in the list? So we already talked about how to make a list, right? So we have our square brackets, and we can store any types of values in lists, right? So we can have strings, we can have integer numbers, anything. And if we want to change a value in the list, right, then what we do is that similar to strings, lists have their numbering starting at 0, right? So in this list over here, this is element 0, and then this is element number 1, right? So John is element 0, and Smith is element number 1. And if you want to change a value in the list, right, then what we can do is, let's say we want to change Smith to something else. So since Smith, I just want to let you know that this meeting is being recorded. So Smith is the first element, right? It's the element at the first index. So over here, if we want to change the element at the first index, then we're gonna say that we're gonna set this friends of 1 equal to whatever we want to change it to, right? And when we want to print a list, what we'll do is it'll print it exactly how we would type it, right? So you would have John, and you have a comma, and then you have these square brackets when you're printing a list, right? Does anyone have any questions about lists?
No.
Okay, that's great. It seems like there's an echo because I don't know. I think that might fix the issue. Yeah. So let's look at some functions that lists have, right? So this is let's say this is our list, John and Smith, as we have from the last slide, right? Now, what friends.extend does is that it will add this list, num collection, onto the friends list, right? So let's say if num collection was just a simple list with like 1, or 1 second. So let's say if num collection was, for example, a list with just a string with 1, then what extend would do is that it would make it John Smith. I'm just going to put J for John and S for Smith, and then it would be 1. And it would just add that list onto the other two. This is a 1, and then that's the square bracket. Sorry if there's any confusion. Now, append is similar, right? Except it only is for 1 value. So what do you guys think that the list friends, John and Smith, would be after you append this new value? So the append function is similar to the extend function in that it adds new values to the end, but instead of the extend function, instead of taking in a full list, it takes in a single element, right? So for example, this num collection could have one element, two elements, three elements, however many elements, and it would just add all of them to the end of the friends list. But this append function only takes in one element, not a list. So it can only add one element to the end. Does that make sense? Okay. So the insert function is also very similar to the append and extend functions, but there's one key difference. So the key difference in the insert function is that you have to specify an index where you want to insert the new value, right? So in this one, if you do insert of 1, what will happen is it will insert the new element at that specified index, and it will shift everything after that one index to the right. So visually what that looks like is that from John and Smith, if we were to insert new value into this list at index 1, it would become John, new value, and then Smith, where I use J and S to abbreviate John and Smith, and then new val is for new value. So what do you guys think the remove function does? Just from the name of it, like what would you, if you had to guess, then what would you think that this remove function would do? Okay, so someone said that it removes a letter. That's very close. Um, so we're does anyone else have any guesses at what this remove function does? So what the remove function does is that it removes the value from the list. So very close to the person that said it removes a letter. Instead of just removing a letter, since we're talking about lists here, when we enter a value, when we put a value in, it will just remove a value. So for example, if we were to put in John here, then what would happen is that the list would just become Smith, and there'd be nothing else. What do you guys think the clear function does? Just off the name of clear, what do you guys think that the clear function would do to a list? So the clear function essentially just takes out everything in the list, right? It clears the list, it empties the list. So what this friends list would become, instead of John and Smith, it would just be an empty list. And yes, you are allowed to have empty lists in Python. It just looks like this. It's a list with nothing in it. And since there's no elements in the list, there's no commas, and it just looks like this. Now, the pop function is very similar to the remove function, except instead of removing a value, you remove an index, right? So in this case, the pop function would remove the fourth index in the list. And as a reminder, indexes are different from like positions. So John is actually at the 0th index and Smith is at the first index, even though John is the first element of the list and Smith is the second element of the list. Smith is actually the first index. So if we want to get like the index from the position, then we just subtract 1, right? If you think about it, Smith is the second element of the list. 2 minus 1 is 1, so Smith is at index 1. And then what this does is that if we want to remove 4 from the list, another way that we can do it is we can find the index of 4 and then we can remove that index. And this is also another key function over here, index, right? This dot index function. And what it does is that it gives us the index of a particular element in the list, right? So in this case, it gives us the index of this element 4 over here. What sort does, it just sorts the list in ascending order. So what does that mean for strings like this? So for strings, it basically sorts them in dictionary order, right? So if you had Bob and Alice as in your list, just Bob, and then you had Alice, right? So we had Bob and then Alice, and I'm gonna put strings because Bob and Alice would both be strings. And then this is our list. If you were to sort it, it would become Alice and then Bob, right? So you would just have Alice, which is A for simplicity, and then Bob is B. And reverse is very similar to sort, it just reverses the order, right? So it it doesn't sort it, it just reverses it. So in this case, it would do Smith, John. In this case, since it's Bob, Alice, it would just do Alice, Bob. Now, if you want to sort it in descending order, then what you have to do is you have to do friends.sort, and then you do reverse is equal to true. And then that's when it will sort it in descending order, which is basically like the opposite order. And then something else that we can do is that we can do copy, which basically just makes a copy of the list, and then in this case we're assigning it to a variable, so friends2 is basically new copy of friends. So friends2 is John and Smith. So does anyone have any questions? Okay, so let's continue. So here's an exercise that you guys can try. Right, so make a list of friends, or actually before this, let's see how we would write these list stuff in code. Right, so here we have our code, right? So over here, I have a list of items, and then I have a list next. Now, what do you guys think that this line of the code, print items of 1, will output? So this line of code, print items of 1, will print the first index in the items list, right? So if we were to look over here, we have our items list, and then this is the 0th index, this is the first index, this is the second one, and this is the third one, right? So what this would do is it would print 2.3 because it is at the first index of items. So it would just print out 2.3 to the console. And then what do you guys think that this line of code, these two lines of code would do? When we print items of 2 after doing this line of code above here. Yeah, so it will be 3.61. And this is because what this does is it sets the element at items of 2 to 3.61. So this will become 3.61. Now, this extend function basically takes this next list and does what with the items list? What it does is that it takes this next list and then it adds it to the items list. So what happens is that the items list becomes 3.4, 2.3, 7.6, 1.5, and then it also has 3.0, 4.15, 2.67, and then 8.8. And if we print items at So that's why we can have a sixth element of items, right? And what it becomes is 0, 1, 2, 3, 4, 5, and then 6 would be 2.67. And then when we have items, when we print items, it'll print all of them combined. So it'll print 3.4, 2.3, 7.6, 1.5, all the elements separated by commas, and then this last one over here. And then if we add an element, it will just append the element and then print the full list with the element. So let's see how this would work. Right, so we have the 2.3 because it's the first element, and then we have the 3.61, and then the 2.67, which is the sixth index, and then all the way over here we have all these elements, right? 3.4, 2.3, and all the way we have 8.8, and then over here we add 12.6, so we get everything with 12.6. Does that all make sense? Does anyone have any questions? Okay, no questions. So here's an exercise that you guys can try. Right, so create a list of friends. It can be anything. And then maybe Alice, Bob, Charlie, Donald. And then you can print the list and then sort the list in alphabetical order and then print that list. So I'll give you guys 5 minutes to try it out and then I'll talk about the solution. Okay, so let's talk about how we're gonna code this, right? So this is our list of friends, and then here we have Zachary, John, Steve, Alan, Tom, and Rob. Right, so over here we're gonna print our list of friends. So what do you guys think will be printed to the console if we're printing our entire list? So when we're printing the console, it would just print out every element normally how you'd print it. So this will just be Zachary without the double quotes. And then it would just separate everything with a comma and put two square brackets around everything to enclose it. Over here, this is the sort function that we learned that can change everything into alphabetical dictionary order, right? So this will print it as Alan. Alan will become the first element, and then John will become the second element, and then so on and so forth. And then descending is just the reverse of ascending. So what this will do is it will put Zachary first, and then it will put Tom afterwards, or it will put Tom afterwards, and then everyone else will go back in reverse alphabetical order. So if we were to run the code, then we can see that it prints Zachary, John, Steve, Alan, Tom, Rob, which is the order that we have here. And for strings, it has this single quote to represent that it's a string. And then if we sort it alphabetically, it will be Alan all the way to Zachary in order. And if we do it reverse alphabetically, or that's what descending means, um, it's just reverse. It's the opposite of in order. So then it would be Zachary all the way to Alan from left to right. So does anyone have any questions? So let's continue. So over here, these are tuples, which are basically the same thing as lists, except you can't change the values inside tuples, right? So once you create these tuples, they're fixed. So that's why this third line doesn't work and it gives an error. And since they're the same thing as lists, they also have the same indexing. So this is the zeroth element. This 4 is at the zeroth index, and then 5 is at the first index. So what do you guys think would happen if we were to use this line of code with these coordinates 4, 5? What do you guys think that coordinates of 1 would be in this case? Yeah, it would be 5 because similar to lists, we access the index, right? We look at the first, which is 1. So 1 is the first index. And then remember in Python, we always have to count from 0. So the first element is at the 0th index, and then the second element is at the first index. So it prints out the second element of this tuple, and then it would just be 5. And this third line over here, where we try to change 5 to 3, would actually not work. Python would give us an error. If we try to do this in Google Colab, it will not allow us to do it. And this is because it's a tuple, and you can't change it when you create it. So some examples for how we can use tuples are here, right? And keep in mind that tuples don't have to be restricted to pairs. They can be 3, 4, 1, however many. And tuples are very similar to lists. So when we make a tuple, instead of using these square brackets, we use parentheses. and then we use commas for the elements similar to lists. Over here I have coordinates and I have x, y, z coordinates, just two tuples, and then I print the index 0, which is the first element of coordinates, which will print out 4. And over here I'm printing out index 2 of x, y, z coords. So what is index 2 of x, y, z coords? What do you guys think that this line of code would print out? Yeah, so this line of code will print out 8 because if we were to do the indexing for these numbers, we have a 0, 1 is the 0th index, 4 is the first index, and then 8 is the second index. So if we look at number 2, then that's 8. And printing tuples is very similar to printing lists. When we print a tuple, then what will happen is that it will just print the exact same thing as we have in our code here for numbers, and for strings it will just include that single quote, similar to how we saw in the lists section. Right, so over here we have our parentheses, exactly how we typed it in code. That's how it comes out over here. So does anyone have any questions about lists or tuples? Okay. Um, I'll continue. Does everyone understand the how the exercise worked? This one? Does everyone understand how to do that? Okay. Um, so let's continue. Sec. Okay, so functions. So what are functions? Functions are basically blocks or sections or just chunks of organized reusable code, right? So we can just use them multiple times. We don't have to put in the same thing over and over and over again. So what are the types of functions? Right? So there's built-in functions that we already get when we use Python. And there's functions in modules. And there's also functions that we can make ourselves. So what are some examples of built-in functions? Right? Print, input, the int and float, those are all examples of built-in functions in Python. Functions in modules are the pal function in the math library and the square root function in the math library, right? Because they're specifically in the math module. Sorry, the pal function in the math module and the square root function in the math module. So those are functions in the math modules that we have to use the math module to be able to use them. And then there's functions that we can make ourselves, and we can make our own functions in our own programs. So how do we do that, right? So what we do over here is we include this keyword over here, def, which is a short version of define, and then we put our function name over here, and then this top part is the definition of our function, right? So we put our function name over here, and we put this parentheses and we put this colon. And if you notice over here, then there's a space, and what this space represents over here, it's called an indent, and everything that is indented under this def word is a part of the function. So in this case, this function over here prints out hello to the console, and then that's all it does. So this over here, the bottom segment of code down here, is what we call calling the function. And when we want to use the fancy function that we created, which in this case prints hello, we just put this function name with a parentheses after it, and we're done. It will just execute. The Python will execute all of the code that is indented below def, which in this case is just print hello. So in this case, it would print top, hello, and then bottom to the code to the console, and it would just the output would just look like this: top, hello, and then bottom. Does anyone have any questions? So over here we have, so there's also something called function with parameters, right? This is a name. So this is a parameter, right? In this case, we called it name. And over here we have our definition with this keyword def. We have the name. We have the name of our function. Oops, 1 second. We have the name of our function over there, and then we can print hello, and then plus name. So what this plus function does is it adds name to hello, and then it will just print hello and then whatever name is. Right? So name is kind of like a variable, but inside a function, when we have like this variable inside of the parentheses, we call it name. We call it a parameter. Parameter is the keyword. It's a new word that we're using here, right? And over here, we have print. We print top, and then we have our function name of parse. And what this does is it prints hello parse, because name in this case is the string parse. And what will happen is it will print hello parse. And then over here we have bottom, which is just top, hello parse, and then bottom. So does anyone have any questions? Okay, so let's continue. So there's also something else special that we can do with the function, which is where we output a value, right? So if you remember in like the math.pal function, it takes in two numbers or two parameters, and then it outputs one value, which is the first number raised to the second number. So this is what we call returning a value. When it outputs a value that we can store in a variable, it's returning a value. And how can we return values? So we have to use a return statement, which is basically this entire line of code over here, right? And what a return statement does is you use this keyword return. So what a return statement does is it's the line of code where you figure out what value you're going to output. And to tell Python that this is the value that I want to output, the first thing that we have to do in our return statement is we have to include this return word, right? And when we include this return word, Python knows that, okay, this is the value, whatever is after this return word, that's what we want to output for our function. In this case, cube is the name of our parameter, and we just return the cube of the parameter, because it's just the cube times the cube times the cube. And then over here, if we were to print top, function name, and then bottom, this would just return 27. So it would do top, 27, and then bottom. And this cube times cube times cube is the value to return. So let's look at an example of a function in code. So over here, I imported math because one way to cube a number is multiplying it by itself 3 times. Another way is use our power function. So I use this key line from math import star, and then we have def, this keyword def, cube function number, and then we print the cube of number is, and then we print it, and then we return it. So actually what happens is that for that cube of the number to actually be printed, we have to print the return value of our function. So, and then the reason that we include this string is to make it a string. Because when we input a number, it's originally a number and it's not a string. So to actually make it a string, we have to convert it into a string. So then this is where that conversion happens. It will just be the cube root of number is, and then we'll return it. And then if we want, we can print it. So over here, we have printed it because we store the return value in this variable val, and then we print val. So what do you guys think the output of this code segment will be? So the output of this code segment will just be 5 cubed. So 5 raised to the power of 3 is just 125. And then since the power function adds its decimal, it will just be 125.0. But up here we have the cube of 5 is, and then on the next line we'll have 125.0. And then we have over here the cube of 5 is 125.0 because we print this value over here. So for example, if I were to take this out, then it would not print 125.0. So this is a key point that return values and print statements are two different things. And return doesn't necessarily mean print. But sometimes in Google Colab, it will automatically print the return value for you. It depends on the scenario. But sometimes it does automatically print it for you. Does anyone have any questions on functions? Okay, so let's continue. So I want you guys to try writing a function that will take a name and then whether it's morning, afternoon, evening, night, another like time of day, and you want to print the name and you want to wish them good morning, good night, etc. Like whatever time of day it is. So good evening, and then you put the name. So good evening, John. Right? And then you want it to be like, I'm gonna call it wish is gonna be my function. So this is what your function call could look like. It's John, and then you have morning. Whoa, this is not really well. Morning, that's better. That's a morning for clarity. Um, and then this will output good morning, John. So yeah, um, I'll give you guys a couple minutes to do that, and then I'll talk about the solution. And if you guys want, you guys can let me know when you guys have finished in the chat, or you guys can just speak, whichever one you guys prefer. Okay, so let's talk about it. Do you guys need a bit more time or are you guys done? So let's talk about it. We have our wish function here, and I just decided to name my parameters n and t for name and time of day. And then over here we have good, and then time of day, so morning, and then we have n, which is the name. And to get them, we use the input function, and then we just say name of wish of name and time, and we print it out. So, for example, if I was to enter a name um, Alice, and if I was to enter a time of day evening, then what do you guys think would be printed to the console after I press enter? So if I were to press enter, then what would happen is that it would print out good evening Alice. Does anyone have any questions on the functions? Okay, let's continue. So let's talk about if statements, right? And this is where these booleans come in, which is what we talked about as one of the types of variables some time back. So over here, similar to the functions, you have if, the condition, and then we have this colon over here, similar to our functions, we have the colon. And then we also have the indent, like our functions, to figure out what statements should be executed if the condition is true. So there's different types of if statements, right? So we have the if, which is it checks if some condition is true, and it will do something. You have the else, which is you have to have it with an if, and if the condition is not true, then by default it will do it. But if the condition is true, then it won't do whatever's in the else block. And there's also something else, which is the elif. So elif is a short form for else if, and it's just the first two letters of both of them. So it's just elif, and then you can do if, and if the condition is not satisfied, but you want to also check for another condition, then you do elif, and then you execute this code over here. So for example, let's say if it was Sunday, you want to do something. If it was Saturday, then you want to do something else. But if it was a weekday, then you want to do something else altogether. Then you could have this is if it's Sunday, else if it's Saturday, and then if it's not Sunday or Saturday, then it's a weekday. So you'll just do whatever is here. So the idea of if statement makes sense. Okay, so let's continue. So we have an if-then statement, right? So we have this boolean is male is equal to true, and then if it is male, so if is male is true, then we're going to print male, and then we're going to print female. So if we have this code, then do you guys think it would print male or it would print female? So in this case, it would print male, because if you have if is male and then you just replace the value of is male with whatever's in is male, so which in this case is true. So if true, and if true means that you execute whatever statement is here. So if true, since it's true, we're gonna print male, right? If false, then false is not true, and that means we would go to the next statement, which in this case is an else, so then we print female. So something else that we can have is these logical operators like or. And I'll talk about them in detail more, but what this does is it will check if male is true or is tall is true. And if one it, and the condition is that at least one of them has to be true. So in this case we know that is male is true. So we know that at least one of them is true. So this entire statement becomes true. And since the entire statement is true and we have if true, then we're going to go ahead and do the next line, which is it will print male again. And then once again, we have is male is true, so we print male. Does anyone have any questions about this? Okay. So let's talk about some comparison operators, which is this is how we can compare numbers, right? So let's say if we want to do less than and greater than. So we can do like we can check if 5 is less than 10 or if 10 is greater than 5. And then this can give us a true or a false, right? So these are like operators that we can use to compare two numbers. And then we can use these operators to turn numbers into booleans, which is what we like to do when we're using if statements. And then for greater than or equal to and less than equal to, you just put an equal to sign after the greater than or equal to greater than sign or the less than sign. So this over here is just less than and then equal to, so it's just less than equal to, and then this is greater than and then equal to, so greater than equal to. So yeah, this should be greater than. Oops, that's a typo. And then something else that we have here is the not equal to sign. So the not equal to operator is actually very simple. It just checks are two things the same or not. So if A is not equal to B, this would be true because A and B are not the same thing. And the equal to is just what it sounds like. It's if two things are the same. So is A equal to A in this case right here? Do you think this would be true or false? True, yeah, it would be true. So do you guys understand how we can use like these comparison operators to get booleans to use in our if statements? Or do you guys have any questions about if statements in general? No? Okay. So here's another if then statement with some examples from the equal to sign and with the comparison operators. So over here we have a variable number which is equal to 1, right? And then we check is number equal to 1, right? So over here, when we're checking if two things are equal to each other, we have to use this double equal to sign versus a single equal to sign, because the single equal to sign is for variables and like assigning things to variables, while the double equal to sign is actually for checking if two things are the same. So what do you guys think that this part of the code would print? So this part of the code will print it is 1 because number is just 1 and 1 is equal to 1. Over here, it'll print it is not 0 because 1 is not equal to 0, and in this case number is 1, So 1 is not equal to 0, and this is why this condition will be true, so it will print it is not 0. Any questions on if statements and logical and comparison operators? Okay, so let's continue. We also have logical operators, right, which are and, or, and not, and they're actually quite simple. And basically means that if both the conditions involving the and are satisfied, right? So when you're doing and, you're going to do condition 1 and then condition 2. And then this entire thing is going to be true only if both of them are true. And in this case, both of these conditions are true because 5 is less than 10 and 13 is also greater than 2. Um, so we'll talk about more stuff about if statements after. Um, Thank you guys all for joining the session. Hopefully this was helpful to you guys. I'll send the link to the recording in case you guys want to watch it again. And then we'll meet again this Saturday um, at 10 o'clock a.m. And I'll send the meeting link 2 days before, and I'll also send a recap email with the recording. Thank you guys, and 1 second. Okay, yeah, thank you guys, and happy coding. And then I'm